So up next we have section 1.3, estimating limits from a graph. So the first thing we're doing in this section is we're working on one-sided limits. Last time we learned about limits in general when you look at a graph approaching a point. So what is a one-sided limit? It's the same notation right here, but now we have a minus or a plus above the A. So all this means is the minus means from the left and the plus means from the right. If that's not clear yet, is going to be clear in a second. So let's look at this graph as an example. So if we look at -4, you see that there's two lines, two limits here. One of them is up top, one of them is down at the bottom. We learned last time that if we just take this and we write limit when x is approaching -4 of f of x, this does not exist, right? Because there's two different limits here, so you can't solve it, right? So if we look at limit when x is approaching -4 of f of x from the left here, because we have this minus above the 4, what does that mean? It means you look from the left of the graph from left to right, so you're going to follow this line here. You're going to see that the limit is 3. So from the left, the limit is 3. Okay, what about from the right? If we have limit when x is approaching -4 from the right, f of x, you're looking at it from the right side approaching -4, and the limit is -2. So you have two different limits here, so you specify which one you're talking about with the minus or the plus. And then for another example, let's look at -1. If you have limit f of x when x is approaching -1, look at it from both sides. The line just in general is approaching 4, so it's just 4. If you have limit f of x when x is approaching -1 minus from the left, what do you get? You look at it from the left, okay, you get 4. Let's write another one. Limit f of x when x is approaching -1 from the right. Same thing, follow the line from the right side, and it's still 4. So if they agree, they're always going to be 4. If they disagree, the just normal limit does not exist. From the left and right, you're going to have two different values. Okay, now we got some practice problems up for y'all to look at, for y'all to do. Y'all can pause it now and try to go through it, and I'll go over it in a second. Yeah. Hopefully by now y'all pause it if you're going to pause it. Y'all did it. So let's go over these one by one. So limit f of x when x is approaching 0 from the left side. Okay, well, let's find that on the graph. This is 0. Boom. Right here, look at it from the left side. Looks like it's going to call that 5.2. Okay, from the right side, let's see. From the right side, it's going to, okay, the same spot. We'll call it 5.2 again. So the limit from the left and right of 0 are the same. Now let's look at 2. From the left side, it's approaching -1. From the right side, we look at this line up here because it's coming from the right, and it's approaching 5. Limit f of x of 2. Well, they disagree because -1 and 5 are not the same number. So this does not exist. F of 2, this one's a little bit trickier. This point up here does not exist because it's an open circle. So the actual point on the graph at 2 is going to be down here. It's going to be -1. And now 4, f of 4. From the left side is approaching 2. From the right side is approaching 2. And since these are the same, the limit of 4 is 2. And then f of 4, this is an open circle, so this isn't a point. But up here, this is a closed circle, so f of 4 is 4. And that's it for this section. This section is pretty short, pretty simple, and pretty similar to the last one. So we're going to move on.